Hello, welcome to Unit 2 of 6th grade math. This unit is all about fractions. Before we actually get into all of this, though, we have finished Unit 1. Your students should be working on their test corrections. Just because we are done with decimals and decimal operations and greatest common factor and least common multiple does not mean that it is going away at all. So if they didn't learn something in time for the test, they should spend the time now looking it up using me during FlexBlock or library or recess, asking you for help, using calculators, and figuring out what they did wrong so that it doesn't happen again when I ask them pretty much the same questions, which is kind of something new in 6th grade. They are used to moving on from a unit and not really seeing that unit again until review time, whereas now we interleave them all over the place. So, in the middle of Unit 4, they might get a greatest common factor question on their classwork. They are obviously on classwork allowed to go back into their notes, and they should, and look it up again and remind themselves so that by the time we get to the end of the year, it's not something that they haven't seen in 9 months that's showing up on the MCAS. Or by the time they get into 7th grade, it's not something that they haven't seen in a year. So we are moving on to fractions and decimals. The good news is all of Unit 2 was learned in 5th grade, if not before that. So our first skill is turning fractions to decimals and back. And this was learned in 5th grade. Turning decimals to fractions is a little bit easier. The place value system that we have has wholes, a decimal, then tenths, hundredths, and thousandths place, and that's really all we care about in 6th grade. So if we are asked to turn a decimal into a fraction, you just would ask them, okay, read me what that amount says. They might say 0.6, and I say, okay, well, as a mathematician, read me what that amount says. And this is 0 and 6/10. Okay, so now sometimes I tell them, close your eyes. They don't have to do that part, but close your eyes, think about a fraction, and re-say what you just said. 6/10. So that's the fraction 6/10. They would be expected to simplify it. In 6th grade, all fractions must be simplified, but we can get to that later. Here, 36/100ths. You can tell because it's 2 spots out, so that's the 100th place. 36/100ths turns into 36/100ths. They would simplify it to 9/25ths. It gets tricky for them when there is a whole number, which shows that they don't quite understand decimals, place value, or fractions yet, but we will be working on that. So this would be 4 and 9/100ths. This is also tricky because of that 0 in the tenths place. So they often will want to say 4 and 9/10ths, but it's in the hundredths place. It's 9/100ths. 4 and 9/100ths means a whole number 4 and 9/100ths. Sometimes they write 49/100ths. Sometimes they turn it into 4/9ths. But if they know how to read this, which they should, they practiced a long, long time in 5th grade, then they know how to read this amount. It's really just connecting this amount to this amount and realizing it's the same thing. Fractions and decimals are a little bit trickier. There are 2 strategies. One of them will always work, and then the other one only sometimes works, even though it's easier. The one that only sometimes works, you can see here, 7/10ths. Well, we have a tenths spot in our place value system. So 7/10ths just turns into 7/10ths. 1/8, however, we don't have an 1/8 spot in our place value system. We can't make equivalent fractions out of 1/8ths that would turn into tenths or hundredths very nicely. So the way that always works, it would work with the 7/10ths as well. And it's what I kind of get them to do anytime. Because if something's going to work every time and they're not used to just noticing, oh, this is 7/10ths, I know 7/10ths, then I'm trying to get them to learn the least amount of things so that they can do them the best. So if your child is having a hard time and thinking that there's just too many things that they have to remember, learn one strategy that works all the time instead of trying to learn two strategies that sometimes work and sometimes don't. So all fractions are math problems. Every single fraction is a division problem. We talked about that in Unit 1. So this is 7 divided by 10. If you did the math, you would get 0.7. This is 1 divided by 8. If you do the math, you get 0.125. And that's just long division. The top number always goes in the house. The bottom number always goes on the outside. Do the long division. An eighth in particular is one that would be good for them to memorize. They should know already, half is 0.5, quarter is 0.25. If they can start remembering that a third is 0.3 repeated, that's good. But an eighth is one that we see kind of a lot in classworks and homeworks and tests. An eighth or 3/8 or 5/8. So if they just start to memorize, oh, this is the same as that, it will help them out, especially when they get to 3/8, when they can, instead of doing 3 divided by 8, which will take a long time, and most kids don't like division as much, they can just do 1/8, 0.125, times 3. And they like that a lot better. 13/20. I can turn 20ths into hundredths. I would just multiply the top and the bottom by 5. Or I can do 13 divided by 20. Either way, I will get 0 and 52 hundredths. Here again, whole numbers, a little bit tricky. Sometimes they just don't know what to do with them. They can either turn into what we used to call an improper fraction, still call it an improper fraction sometimes, but more accurately is called a fraction greater than 1. And we'll go over that. But they could do 49/8, which is the same then do 49 divided by 8. They'll get 6.125. Or if they recognize, oh, this is a whole number, this is a fraction, I'm going to have the same whole number, and I memorized that fraction. 6 and 1/8 is 6.125. Equivalent fractions. They learned in 5th grade. Simplest form. They learned in 5th grade. However, they were not expected to write all their answers in simplest form in 5th grade. They now are. There's a lot of times that they'll give me an answer and I'll say, oh, well, that's the right amount, but it's not the right answer. So that's a hint that they have to put it into simplest form or lowest terms. Equivalent fractions, we start out making sure they know how to make equivalent fractions. So you might be doing 7/8 turning into 49/56. You do that by multiplying by 1, 7/7, or any form of a fraction where the top number and the bottom number are the same. What you're doing is multiplying by 1. And anything multiplied by 1 is the same amount. So 7/8 is the same fraction as 49/56. I say, at school, I'm Mrs. Hannah. At home, I'm Sarah. I'm the same person, I just have different names. That's the idea here. Same fraction, just different numbers. So again, we rarely go up and make the digits in the fraction bigger, but it's important that they understand that they can. More often, we go down and make the digits smaller, although the fractional amount is the same. But we tell them whatever you do to the bottom, you must do to the top. So 7/8 is never going to be 7 in anything else's. Because if I'm going to turn an 8 into something else by multiplying or dividing, I have to do the same thing to the top. A lot of times the kids will say, well, I just multiplied by 7. It's a little bit picky of me, but it's important that they realize, oh, they're not multiplying by 7. They're multiplying by 7/7. That's multiplying by 1. Multiplying by 7 would be completely different. The only time, so equivalent fraction and simplest form, when they get really good at it, will help them do problems like this really fast. If they're not good at equivalent fractions in simplest form, this will take a long time because they have to find a common denominator between 14 and 16, which would be a really big number. Instead, though, I'm pretty decent at realizing, hey, 7/14, that's 1/2. Hey, 9/16, that's a half and an extra 16th. Together, this is going to be a whole, a half and a half, plus that extra 16th. 1 whole and 1/16. Way faster than doing the algorithm. And that's what we want from them. We do expect them to use the algorithm for a lot of things, but we want them to be fluent and be able to efficiently solve their math problems. So when we're doing simplest form, we use the ladder method, just like when we did greatest common factor, or least common multiple, or prime factorization. You put both numbers in a ladder, pull out the smallest prime numbers, and then you'll know you're done when the numbers at the bottom are relatively prime, the bottom of that ladder. And so 1836, turns into 1/2. Some kids can recognize that right away. Say, oh, I can divide both of them by 18. That's great. Some kids can't, and that's okay too. They might say, oh, they're both even. I can divide by 2/2. Then I'll get 9/18. Oh, I know 9 is half of 18. That turns into 1/2. Maybe they don't know it. Divide by 2/2. Divide by 2/2 to start. 9/18. Divide by 3/3. 9 divided by 3 is 3. 18 divided by 3 is 6. Divide by 3/3 again. And finally you get to 1/2. It doesn't matter how many steps it takes for you to get to the simplest form, as long as you get there. A hint that you're done and you're in simplest form or lowest terms is if the numerator is 1. When that top number is 1, that means you only have one piece out of however many pieces the whole is cut into. Can't get any smaller of a digit than that. So if the numerator is 1, you're done. If the numerator is 2 and the denominator is an odd number, 2/3, 2/5, 2/81. Well, the only factors of 2 are 1 and 2, and odd numbers can't be divisible by 2. So 2 and whatever the odd number on the bottom is relatively prime, and those cannot be made smaller by dividing by the same amount on the top and the bottom. So it's lowest terms. If the numerator and denominator are consecutive numbers, 3/4, 11/12, 30/31, all consecutive numbers, they will not have any common factors except for 1. That means they're relatively prime. That means that that is as small of terms you can get. It is in lowest terms, simplest terms. And then all of them are coming back to when the numerator and denominator are relatively prime. When there's no number that you can divide both of them by, except for 1, which wouldn't make a difference, you are done. It's in lowest terms. That's your answer. Converting mixed and improper fractions. So we do call them improper fractions. That's what I grew up learning. That is the pretty common phrase in life. I don't know how many people talk about improper fractions, but there is a slight change, and the students do need to know both phrases. Improper, the word improper means wrong, and these fractions are not wrong. In fact, in 7th grade, there will be times when the improper fraction is the only correct answer. So we still, like I said, call them improper fractions, but more accurately, they are called fractions greater than 1. They are 29/4 is a fraction greater than 1, or an improper fraction. You can tell because the top number's bigger than the small number. It just means that this amount is bigger than a whole. So converting between mixed and improper fractions, or fractions greater than 1, is another thing they learned in 5th grade. Some of them are really good at it. They might not quite know why it's happening or how it's happening, but they memorize the steps, and that's awesome. Others, not so much. We use the acronyms MAD and GLAD to remind ourselves of how to do the steps. If it's a mixed number, you make it mad. If it's a fraction greater than 1, you make it glad. Greater than 1, G. And to do that, for example, 7 1/4. It's a mixed number, I can tell, because it's a whole number and a fraction. I'm going to make it mad. M is for multiply, A is add, D is denominator. This very colorful thing is in their notes. It might not be that colorful in the notes, depending on if our color printer worked. So first, you take the whole number and multiply it by the denominator. When I used to teach 5th grade, I didn't have these acronyms, and I would just say, do the backwards C. You start on the bottom, move around and up. You start at the bottom, multiply and add. So what we're doing here is we're saying, okay, there's 7 wholes. If we're looking at fourths, that means I have 7 wholes broken into fourths. That's 28 pieces in my wholes. If I have 7 cakes and I cut each one into quarters, I have 28 pieces of cake. A is for add. You add whatever's left over. So I have 28 pieces plus that 1 because of the 1/4. That makes 29 pieces. Denominator stays the same. 29 fourths. 7 1/4 is exactly the same as 29 fourths. The D on both of them stands for denominator stays the same. The kids always want the D to stand for done, but they're not done. They need to make the denominator the same because 29 is definitely not the same as 7 1/4. For improper fractions or fractions greater than 1, you make it glad. You go divide. It's a little bit of a stretch, but they remember it. As I said before, this fraction is a division problem. It looks like the division sign, but instead of the dots, as you see here, there's just numbers. You take the top number, put it in the house, divide by the bottom number on the outside of the house, the division house. So go divide. 29 divided by 4 is 7 with a remainder. This is the only time in 6th grade that they're allowed to use their remainders or leave their remainders. The 7 becomes your whole. The remainder becomes the numerator. So L is leave the quotient whole number as the mixed number whole number. A is always put the remainder as the numerator. D is denominator stays the same. Still fourths. If it was fourths to start with, it's going to be fourths the whole time. If it was thirds to start with, it's going to be thirds the whole time. We don't make things glad as often as we make them mad. Because, as I said, when we get to 7th grade, sometimes the fraction greater than 1 is the only answer that they're looking for. It's not improper. It's just a fraction greater than 1. When we get to our ratios unit, you can't change it into a mixed number because that's not a ratio anymore. So we are looking for maybe 29 out of 4 or something like that. We do make them mad more often to manipulate the fractions a little bit when we're subtracting or multiplying, definitely. Not glad as much, which is nice because the acronym for glad is a little bit of a stretch on all accounts. Adding and subtracting fractions is learned in 5th grade. It's actually learned possibly in 3rd. They definitely do it in 4th. And then they spend a lot of time in it in 5th. I call addition and subtraction the baby operations. They are the ones that you learn when you're a baby, when you're in kindergarten, 1st and 2nd grade. And like babies or toddlers, they need things a certain way. Otherwise, they throw a fit and nothing is right. For adding and subtracting decimals, like we did in Unit 1, they need those decimals lined up in order to do it correctly. When we get to algebra, for adding and subtracting terms, they need like terms. Don't worry about that if that doesn't make sense yet. For adding and subtracting fractions, they need like denominators. Those bottom numbers have to be the same, or else our baby operations aren't going to play along with us that day. Once we make common denominators, keep it the same. We made it the same on purpose for a reason. Keep it that common denominator. So 14/15 plus 3/5. Some kids, if they're good at their multiples or recognizing patterns, can realize, oh, I can turn this 5 into a 15. Some can't. And they will do 14/15 times 5/5 and 3/5 times 15/15. And that's okay. They'll still get to their answer. It'll just take them a longer time. I, though, am pretty good at recognizing, hey, 15 and 5, the least common multiple, or here the least common denominator, is going to be 15. I can keep this one the same. Just multiply by 3/3. So this 3 times 3 becomes 9. This 5 times 3 becomes 15. I add them together. 15 stays the same. And I can keep my fraction this amount. 23/15 is correct. It's a fraction greater than 1, an improper fraction, but it's a correct answer. They could change it to 1 8/15, and that's also correct. In 6th grade, we accept both forms. 4 1/3 minus 1/2. Here, the common denominator will become 6. This is where it gets tricky. So 4 1/3 becomes 2/6, but I can't do 2/6. Take away 3/6. If I have 2 of something, I can't give away 3 of them because I don't have 3 of them. So there is 2 options here. There's our equivalent fraction, our mixed number that I would take. For subtracting, the first option is to regroup, which really shows a pretty good understanding of what they're doing with fractions. I'm going to take one of those wholes from the 4 and break it into sixths. So the 4 becomes 3 because I took a whole away. The 2 becomes 8 because when I took that whole, it was made out of 6 sixths. So I'm going to take those 6 pieces and add it to the 2 pieces I have, make it 8 pieces. This expression is the same as this one, just written in a different way. A mistake that kids make a lot is they cross off the 4, make it a 3, and then turn this into a 12. Because we are used to base 10 operations. When we're subtracting, we're used to moving next door, crossing it out, making the ones place or wherever you were before 10 greater. But fractions aren't base 10. We have to focus on whatever the denominator is and know, okay, that's the amount of pieces that I'm working with this time. Once it's 3 8/6, you can take 3 sixths away from 8 sixths and keep the whole number the same. The other option is to make it the fraction greater than 1. Some kids will do this right away because that's a strategy that works every time, and they don't have to worry about what the denominator is and worrying about making sure they're adding the right amount to the top. So they multiply. 6 times 4 is 24, plus 2 is 26. They change it into 26/6 minus 3/6. That's 23/6. An improper fraction is okay to have. They would have to simplify it. They're both even numbers. So they would get 13/3. Multiplying fractions was learned in 5th grade. Multiplying is an easy one. It's nice. It's not a baby operation like addition and subtraction. It can deal with doing harder things. When you're working with decimals, multiplying, not a baby operation. It can deal with decimals being out of line. We'll just figure out where the decimal goes at the end by counting the swoops. With fractions, multiply straight across the top, multiply straight across the bottom. Just remember to simplify. The only tricky part is that you cannot multiply mixed numbers in 6th grade. You can, but it takes a few steps. It's a little bit too hard for them to understand at this point how to do all those steps. So in 6th grade, you can't multiply mixed numbers, but I'm still going to make them. And I say that a lot. When they will just say, oh, well, that's 4 and multiply across the top, multiply across the bottom, 4 and 1/6. Nope. This is 4 1/3 happening half of a time. So it's going to be less than 4. If this was happening one whole time, it would be 4 1/3. It's happening half the time. So I know it's going to be less than this amount. So I give them a hint. Well, I've asked you to multiply mixed numbers, but you know you can't. What can you do? They should turn it into a fraction greater than 1. 4 times 3 is 12, plus 1, 13 thirds. The D stands for denominator, stays the same. Now we can multiply across the top, multiply across the bottom. We get 13/6, which can be our answer. Or they can change it back into 2 1/6, and that's okay too. I would accept either one of these. Those are in simplest form. Even though this is an quote-unquote improper fraction, it's simplest form. So either one works. Dividing fractions, the correct term to learn, and what I believe they learned in 5th grade. They definitely learned how to divide. There's just a few different phrases that were taught. But mathematically what they're doing is multiplying by the reciprocal. The first number stays the same. You turn the division symbol into a multiplication symbol, and then you flip the second number. The reciprocal is just a fraction flipped upside down. A way that we teach it and remember it in our classroom is SIRS, because we have a little bit of a boot camp theme going on. So we say dividing fractions, and they say SIRS. Yes, SIRS. SIRS just stands for same, inverse, reciprocal. It's still the same as multiplying by the reciprocal. You keep the first number the same. You do the inverse operation, just the opposite operation. And then you multiply by the reciprocal. Flip it upside down. Just like multiplication, you can't divide mixed numbers, but I'm going to ask you to. So you need to turn this mixed number into a fraction greater than 1 before you can do the multiplication. So here, keep it the same, multiply, flip it, you get 70/45. You have to simplify it. Both can be divided by 5. So divide by 5, divide by 5. There you go. If you're not good at recognizing that they can both be divided by 5, put it in the ladder for the ladder method. Try and pull out 2, and then 3, and then 5, and you'll get to this eventually. There will be some 6th graders who are able to recognize how to cross multiply. So the 5 and the 15 already have a common factor. It's 5. You can cross out the 5, make it a 1. Cross out the 15, make it a 3. 14 times 1 is 14. 3 times 3 is 9. You get the simplest form way faster. But not all 6th graders are there yet. So I only teach it in small group for those kids that are ready. If your kid is ready, and I haven't taught it to them yet, feel free to show it to them if they're having a hard time and that multiples or common factors is something that they're good at, they can use it. In general, as always, if it's math, they can do it. It doesn't have to be the way I taught them. You don't have to wait for me to teach them something if that's up to you. Don't feel like you have to be teaching them. That's my job. But if you are helping them and it's something that works at home, as long as they can do it on their own and show me how it works in school, I'm all for it. Again, 4 1/3 has to be turned into 13/3 first. When they're doing this, they should rewrite the problem with the fraction greater than 1 first. Too many kids try and convert it into the fraction greater than 1 and multiply it by the reciprocal in the same step. They try and go straight to here. And 4 to 5 times, they'll forget to do the reciprocal. So we make them do every single step. This becomes 36/3. I can divide both by 3. I got 12/1, which is just 12. Anything over 1 is just that whole number. 2/1 this would just be 2. And that's it. Less than half an hour, almost. That's our whole unit. It will take us about a month. It will be hard, especially when we get to word problems, fraction word problems. I demand that they write pictures, draw pictures. They are things that are happening in real life, and it's hard to understand what's happening with fractions. So drawing out what is happening is the best way to understand if it's multiplication or division. And often if they draw the picture, they don't even have to do the calculation because the picture shows them the answer right then and there. So thank you so much for watching this. Please let me know if you have any questions or comments. I really appreciate all the support from home. Have a great night.